Hello, this is Roberto and this is the HVAC is my channel. Today we're going to be talking about dedicated outdoor air systems part 2. So for this video, we're going to be checking on air distribution configurations, okay? Alright, so let's get into it. So what I'm going to do, as you can see in here, there are 4 types. I'm gonna put this in pink so that way everyone can see it better. So number 1, DOAS, so that's gonna be directly to zone or space. Okay. So then number 2, DOAS, intake of HVAC unit, DOAS, outlet of HVAC unit, or DOAS directly to ceiling plenum. Okay, so to put this into perspective, what does DOAS do? So DOAS is going to be in charge of ventilation, right? So I'm gonna put in here, this takes care of ASHRAE 62.1. all right, so ventilation. So with that, ventilation is taken care of. But what about heating and cooling? In other words, conditioning. So for conditioning, we're talking about the local HVAC unit. So this is going to be the local HVAC unit, local equipment, right? Okay, so usually this local HVAC unit, what they do is they recirculate air. So recirculation. Okay, in other words, you have supply and return, but you need to find a way to tap ventilation, like the outside air. So as you can see in here, this is the rooftop unit, and I'm gonna put in here, air is coming out from outside air. And of course, this unit is going to have heating and cooling coils. So this unit is also provide conditioned air, because it's not just gonna bring, if it's summer 110 degrees, it's not just gonna bring all the way inside like the same temperature, the same humidity. This is going to also condition the air, and then we're gonna have in here conditioned air. That it represents the outside air in here in the unit. So what we're going to do in here is an example actually. So what we can do is in here, let's call this as a room. Let's call that this is a conference room. Okay, so this is going to be room. So depending on the architect could call it 101, 112, whichever. So this is a conference room. So what I'm gonna do is I need to provide air conditioning to that room, okay? So, and again, I'm gonna put in here the following. Number 1, that's what we're analyzing today. All right, so let's put that as a title very quickly, so that way this can be neat. So number 1, okay, there you go. Today we're talking about this. So this is DOAS, and then this is directly going to the directly to zone or space. Okay, that's the title, to zone or space. Okay, so to show this, what I'm gonna do is I'm gonna make a quick example. Okay, so let's do this little by little, and everyone's going to understand this. Okay, let's see. I'm going to make in here my conference room. See, this is gonna be my conference room. There you go. If we see this conference room from the top, so this would be a top view. Okay, so in this conference room, what we have is I'm gonna put this as red, or as red. This is my diffuser right here, diffuser, okay, and then I'm gonna have other 2 diffusers. Let's put that as blue. Okay, so I'm gonna have 2 other diffusers in here, 1 and 2 right here, 1 and 2. There you go. Okay, so now in here I'm gonna call this my conference room. There you go, conference room. Okay, so it happened that after doing my ASHRAE, so I'm gonna put these 2 factors in here. So you know, the standard ASHRAE, depending on the location, ASHRAE, after doing my calculation, ASHRAE 62.1, depending the year, depending on the location, ASHRAE 62.1 said that for this location I need 70 CFM. So my outside air has to be OA, has to be equal to 75 CFM. And then we did this calculation before in other videos, but it's a very easy calculation, okay? So we're doing this for conference room 101, okay, see? And then the other one is going to be for heat load calculation based on the heat load calc. It said that this space actually requires a 1 ton unit. 1 ton, see? Remember, the heat load calculation could be done by Trace 3D. I'm not sponsored or anything. Trace 3D, Carrier Hub. So there's more, but let's put that for now. Okay, so we have these two aspects. So who's taking care of this? We're going to put in here the DOAS is taking care of this, but now we're doing the distribution. And then for heat load calculation, how are we going to condition the air? We're going to choose, there is different systems. I'm gonna show you in the internet. You know what? Let's do that right now. So what I'm gonna do is I'm gonna pull this to the side, and then in Google, what we're gonna do is let's put, depending on the base of design, it could be Daikin, Train, or Mitsubishi Electric. Okay, let's put in here Mitsubishi Electric. So Mitsubishi Electric uses my link drive. There you go. So for my link drive, I'm gonna put in there, cannot be reached. Let's go again. My link drive, Mitsubishi. Depending again of the manufacturer basis of design, this is Mitsubishi Electric heating and air conditioning. So we're going to go here to the Caribbean and Latin American markets, and then USA market. We go to US products. So for example, if I'm trying to do a VRF system, I'm going to check in here VRF heat recovery. So this is just for the sake of showing you the options. So for the options, what we have is the following. Yeah, let's do this again. Go VRF recovery again. So for VRF recovery, so these are my options. So what we're talking about this location. So we're talking about part 2. So in a conference room, I need to provide outside air. Okay, DOAS is taking care of that. The heat load calculation tells me that I need to provide 1 ton of AC or heating. So for 1 ton of AC, in other words, the local HVAC equipment is going to be this. You have options. You can put a hydronic, you can put, depending, it's going to be in this case air, it's going to be air, it's not going to be water. So we can put this multi-position air handler, floor mounted, ceiling suspended, ceiling concealed. So you have options, ceiling cassette, wall mounted. So we're gonna go for this ceiling concealed FCU, fan coil unit. So let's click on that. And then for this, you have low static, you have medium static, you have high static. So we don't need high static. We don't have a lot of static pressure. So we can do a medium static. And since it's telling me you need 1 ton from the heat load calculation, we're going to put in here 12. P12. 12 is 1 ton. So click in there. And this allows you to get the information in here. Submittals. For the submittals, we go submittal right here. There we go. From the submittal, I'm going to download this. And we can see this. But now that I downloaded it, so what we're gonna do is we're gonna analyze this a little bit, okay? So for a 1 ton unit, so this is the unit. See, as you can see, it says 1 ton, 12,000 BTUs hour medium static ducted. This is going to take care of the AC, heating and cooling, okay? So for this, what I need to know is the CFM. So let's go to the part where it says CFM. There we go, the fan. So the fan goes here, it says airflow rate. So for airflow rate, I have a total CFM of, see, we have 3 speeds, 265, 318, and 371. So what I'm gonna do is I'm gonna take the high speed. So I'm gonna make it as 370 CFM. All right. So again, as you can see in here, CFM 370 CFM. Okay. And then you have more information in here for coordination with the vendors, with the architects, for clearances. So this is, you have schematics in here. How is the FC unit, air inlet, air outlet. So see, as you can see in here, air inlet, air outlet. So technically you can tap your DOAS system, see, intake and outlet of the HVAC unit. So you can tap from the back or from the front. Okay, and the last one is going to be directly to the ceiling plenum, but that's going to be for other videos. But now that we know this data, we're going to continue with this analysis. So in here, where are we? So one ton unit, and this is going to be DOAS. This is going to be my FCU. Okay, in my FCU, it's going to be an FCU that is horizontal. So in other words, this is going to be something like this, There you go. All right, and this is going to be on the ceiling. Okay, so 1 ton, and then my CFM for this, we were saying, is going to be 370. I'm going to make this better. So this is going to 370 CFM. All right, so technically this space, which is the conference room, it has to be very quiet, and we're going to have 370 CFM. So we can split this 370 into 2 diffusers. I'm going to put this in blue steel, and then I'm going to put this as a diffuser, see, like an X. Okay, let's make this a little bit nicer again. So, because sometimes everyone uses this as a cheat sheet or something like that, see? I'm making these crosses, so that's gonna be actually my outside air for conditioning, not outside air, heating and cooling. So 370, so this is gonna be 185 actually. So this is gonna be 185, this is gonna be 185 of conditioning, see, CFM. Now the other one, I'm gonna put this in red. If we go in red, let's do this. Oh my gosh, no, not good. So I'm being a little bit picky on this, so I'm gonna make it very straight, there we go. And then for this, what we need after doing array 62.1, I need 75 CFM, there you go, 75 CFM. So this is number 1. See, as you can see, these are decoupled. I could say in here, this is directly to the zone, so this is decoupled system. Okay, all right, I'm gonna give you all a little bit more detail on this. Okay, so number 1, okay, because this is part of the design, usually these FCU units, you have the option to put this FCU in the space, which is the conference room. However, it's not preferable to put it in the conference room because of the noise. Okay, so I'm gonna put this FCU right outside. Let's put it right here. See this FCU? I'm gonna put it outside right there. So that's my FCU. I'm gonna put in here FCU, and usually this has some kind of nomenclature, FCU number 1. And in a building, you're gonna have maybe 30, 40 FCUs and then VAVs and everything. Okay. So now I'm gonna put in here my ductwork. This is the supply. See? And then from the supply, I'm tapping here. See, 1. See, what is it? 1 and 2. There we go. What about the return? The return could be directly located here. I'm gonna move this a little bit to the side. Let's see, I'm gonna move it here. Let's move this FCU. See, it's not the best idea, but depending on the architect, depending on coordination with coordination with the architect, see, we can move this in here, and we can move this in here. And remember, this is above the ceiling. There you go. Okay, so in other words, that's going to be my return side. So this is RA, see, RA. So if it's 385, this should be sized for 370. Okay, 370. But someone might be wondering, this is 370 of RA, return air. And this is 185 of supply air. And this is the FCU. So I'm gonna put FCU. And again, this is the local HVAC equipment. That's the local HVAC equipment. All right. Okay, so this is return and supply, right? And you can size the ducts. That could be for another video. Okay, and remember this is above the ceiling tile, ACT, and the unit is outside to avoid noise. If there's no other choice, then you would have to put it inside, which is not a good idea. But this is 370, but you might be wondering, how is this returning? Because this is 75, so shouldn't it be 370 plus 75? That depends. You need to find out your part of return. But now we're talking more about design. I don't want to get sidetracked. Okay, so we're gonna make this a little bit in red. So this is gonna be in red. Let's check. So from here, see, from here, from the HVAC unit, you're gonna have a main duct and you're gonna have the branches. So for example, if my main duct is coming like this is my main duct. Okay, so from the main duct, I'm going to tap out, see, a VAV system right there. I need a terminal unit. So for this, I'm gonna put this in here, a flex. Oh my gosh, I'm gonna put in here a flex right here. But before that, I'm gonna just do this. Just bear with me a little bit, and there we go. I'm gonna put in here a flex. There you go. So I'm gonna put in here a terminal box. Yeah, the reason is because the conference room is not constantly occupied. So this is basically based on demand control ventilations. So this is gonna be a VAV, otherwise I would put a CAV. So I'm gonna put a nomenclature VAV1. Why is it a VAV? Because this is going to allow me to provide enough or maximum outside there depending on the occupancy. And who's gonna tell me that? Who's gonna let me know about how much occupancy I have in here? That's gonna be taken care of by the thermostat and the CO. See, for the thermostat CO. So I'm gonna put a thermostat and then CO2. CO2 sensor is going to let me know the occupancy levels inside this conference room. Based on that, this is going to be connected to the VAV, and it will be open or closed or everything. Okay, so as you can see, number one distribution arrangement is DOAS is providing outside air, and this is decoupled, so this is recirculation and everything. See, now what I'm gonna do is I'm gonna show you this in a schematic, like elevation type of thing. So I'm gonna go here and put this in red. So let's go here. I'm gonna put this in red. I'm changing colors. So as you can see in here, this is the DOAS. Okay, so I'm gonna go down. What we call this is usually a riser, right? So the riser goes like this, and then this goes like this. See, this is the main trunk, and then from there I have a VAV box. So I'm gonna put like this, see, like this, and then go down. So this would be the, there we go. Let's go back again. So this is outside there, 75 CFM OA. See, outside there. So this is dumping, and in here I have my VAV box. Okay, and this is my riser. See, duct riser. Oh, outside there. Okay, so now in the same schematic, I'm gonna show my other unit. So the other unit is yellow. I'm keeping consistent with what it is in there. Okay, so I'm gonna put this unit is gonna be located outside. See, this is the ceiling plenum, so this is FCU, it's outside. And then I'm gonna make some my main duct in here. See, I'm gonna have a main duct, and then from the main duct I'm gonna tap down. There we go. I'm gonna tap down. There we go. Okay, and now I'm gonna have in here my diffusers, and each one is providing 185, right? So 185, this is going to be 185, and in total 387. And in here again, so we have, it's returning Of course, in here I'm gonna have like a grill, but this is returning 370 to the FCU unit. All right. Okay, so again, how this is actually gonna show? See, this is so the 370 is returning to the FCU, but how this 70 is returning to the DOAS systems, because this is the DOAS. I'm gonna put DOAS in here. See, how is it returning? The return side could be depending on the path. So we can put transfer grills, transfer ducts like this. And the open ceiling plenum. I'm gonna put in here, this is a transfer duct. Transfer duct. And all of this is in the open ceiling plenum. So I'm gonna put another line, and yeah, it's just a few more minutes and we're gonna be wrapping up this video. There you go. So everything is in here. So we call this I'm gonna put in here, hold on, just 1 minute. There you go. So I'm gonna put this in here. This is the ceiling plenum. Ceiling plenum. So the space between the deck or the slab and also the ceiling ACT tiles. This is very important to coordinate with the architect, because if you have like low spaces, for example, they give you 12 inches and then you already agree with that, it's very difficult to accommodate all these devices, ductwork, because remember, this is only HVAC. What about piping? What about fire protection? What about some cables, electrical? So you need to accommodate as much space as you can get, okay? All right, so I hope you enjoyed this video, and if you did, leave any comment. It's very helpful for me, and then subscribe, okay? I'll see you in the next video. In the next video, it's gonna be number 2, intake of HVAC unit. Bye-bye, thank you.